different process and also a use case of it. Okay. So yeah, as I told you, so this is the agenda of the section. So it's going to be for 1.5 hours. So this is what we are going to cover. So I'll be telling you what is predictive analytics and what are the levels of predictive analytics. Levels is nothing but the process of predictive analysis. And I'll be giving you an introduction about what is meant by big data and how it is related to predictive analytics, and what is machine learning and its own process, and why predictive analysis is very important, and also what is the tools and skills that you need to master uh, to excel in predictive analytics. Okay, and also use case. Yeah, so we'll move on. So the first one that we're going to see, that I already told you, is predictive analytics. So what is meant by that? So we'll just split up the words. Okay, so the word predictive, it means, so you're just predicting something. It may be any event, so something in future or something that has already happened. So with the information of something that has already happened, you're going to predict the future. So predict an event or a result or anything it could be. Okay, so that's what normally prediction means. So and anyone says you just predict something or guess something, so it's a prediction, right? What is meant by analytics? Okay, so when you use statistics, so you are like in engineering, so you have known what is statistics in your basic math. So basically, when we have like lots and lots of data and how to handle those data, so if we are so confused about it, we have to organize the data and get insights about it. So when I say insights, I should get some sort of information, some sort of useful information in it. So I can use math or machine learning or anything I have uh, with computer science. I can combine all these, so to produce or to have an insights that is helpful for, again, to predict. Okay, so this is totally what a predictive analytics is. So basically, I'm just having some data and I'm going to do a lot of math to it, and I'm going to insert a lot of algorithms in the sense, lot of, yeah, exactly, like just like a lot of formulas and a lot of math and a lot of statistics, basically. So I'll just involve that and my raw data, that is the data, that is the information that I told. So basically, I said that I'll be predicting predicting something for the future with the help of the past information, right? So with the past information, I will be applying my analytical skills. So that's what your analytical skills, and then I'll be predicting it. So you can see this is very helpful for business purposes, because you can see that a large percentage of companies are not, they don't want to take risk, obviously, right? So if they don't want to take risk, they have to predict. So I'm not telling it's going to be 100% uh, true whatever we are going to predict. So whatever the prediction analytics is, we can't get 100% result, but still, it, just imagine how far it can be helpful in a business. Okay, so you can literally predict, or like you can guess, okay, this can happen, there's a more probability that this maybe a loss can happen or a loss of a profit can happen. Okay, so it is not only in business, basically in every single way it is very important. Okay, so that's why we are going to see about predictive analytics today. Okay, as I told you, the process of analytics. So there are four process of analytics: uh, descriptive, diagnostic. Okay, before going into four levels of analytics, I have to tell you with an example so that it will like be very helpful for you. So yeah, imagine that you're going to a doctor. Okay, so you're going to a doctor. You have some sort of fever or anything. Okay, so what will the thing that first? What is the first most thing your doctor will do? So there'll be describing you. Okay, so first, that's one, it's your descriptive. So basically what they will do, they will um, you can just say, they will just see you first, right? Okay, how sick you are you so sick, are you so ill that you can't even walk, or are you okay, or like are you normal? Okay, or you just have some fracture or something. So basically the first thing a doctor does or anyone does while they are going to give a treatment is going to first see you and observe you and take the report of you. Okay, so that is going to be our first step, and then we are going to go for diagnostic and then predictive, where we are going to predict the results, and then okay, and then we are going to go to prescriptive. So basically we are going to go all these steps to have a output. So I already told you what is going to be the output is. So output is nothing but we are going to predict something. Okay, I'm going to say this example with doctor, but you can just totally relate that with how you're going to predict it with any sort of data. Okay, the first one, descriptive. So what is descriptive analytics is that, so mainly if you're going to, as I already told you, if you're going to, it's just nothing but a doctor seeing you and telling that, and just observing you and knowing that, okay, you are a very sick person, like you're not normal and you're a sick person and you need some sort of help. Okay, and okay, this is what a basic thing that a doctor will do. So that's the first one. So the descriptive analysis, the first most step, and it is very essential because just think about any sort of data that you want to forecast about. So the usual thing or the common thing that we will always that always comes into mind when we say about forecast or predict is your weather, right? So you know what is the weather right now or in the past, obviously, because we have data for everything. But what if I ask you, or in next week at the same time, on Saturday, what will be the weather? Or will it be sunny or will it be rain? I can't say that, okay, it's going to be sunny, it is like 100% going to be sunny, but I can have a prediction. So that's how you just take your phone out and you can just Google the weather forecast for like next week, and you can just see all the things, like all for each day of the next week you'll be getting what it is going to be, or precipitated, or it is going to be sunny or cloudy or whatever it's going to be. So how it is forecasted is that I have a data of my previous information, that is previous weather information. So I have like lots and lots of data. So this is how this month, during this month, mostly at this week, it is going to be like this, because I have like lots of data to compare that, and I can get into a solution, right? Okay, just like that, you can just think of a doctor. So basically, a doctor, just imagine if a doctor just sees you and tells you, okay, fine, that okay, I can see you and you're sick. Okay, so it doesn't help you in anything, right? You have to go to the next point, that is, you have to make a treatment for you. So this particular, the first step was for just seeing your data of your past uh, information of your weather or anything, just seeing and observing how the graphs went, whether they went so high, or even, when I say graph, you know what is graph means, right? Like when if it is going to be very highly precipitated, or very highly rainy, highly sunny, or it is going to be, the weather is going to be so cold. So you can just see and observe. So that's what your descriptive analytics is. Okay, and the next one is diagnostic. So what does diagnostic mean is that, okay, now you know that it is going to be, let's just take this weather itself. So if you're going to see whether is going to go very high temperature, or whether a temperature is going to go very, very less. Okay, so why it is happening like this? What are the factors that is affecting my weather? Okay, is there any cyclone that is formed? So if a cyclone is formed, you can't just take in random data and just say that, okay, last month at this week, okay, this was the thing, this was the weather. So I can't just say that, okay, this month also it will be the same. But because there can be a new cyclone formed. So when a cyclone formed and how it is actually affecting the data. So there is so many parameters that will actually affect your variables. Oh, okay, not a variable. So basically it will affect your temperature right over here. And the main example I can give over here is, yeah, as I already told you, a doctor just can't, when you go to a doctor, that a doctor just can't say, okay, you're just ill, right? So you have to take a next step. So that next step will be why, what happened to you, and why actually it happened. So basically, if you're ill, when a doctor analyzes more and asks you, I mean, and ask you or found you, like why you actually became ill. Did you eat something? Did you have food poison? Or is it cold, common cold, or is it any other virus disease? Anything, a doctor should, the next step it will be taken to why and what are the parameters that involved in it, right? That's exactly what we will be doing with data. The data that is nothing, data is nothing but your information. Okay, we'll come to what is data and what is big data and stuff, but just for now, this is the process of how you will do a prediction. So basically prediction is not like guessing or some magic or something. So it has some formulated math and statistics, probability added to it to make it more accurate as possible. Okay, the next one is predictive analysis. Okay, now it comes. So now what happened, now you can just see by the word and you can tell now we are going to predict with the data that we already saw. So first, what was it? You just took the data, you just observed it, how vary how variance it has, how much variance it has, and how much mean and median, whatever, like how basically how, whether it is going or whether it is rising or whether it is decreasing. You're just going to report and observe that, and the next one is you're going to find what are the parameters that affect that particular data, and the next one is you're going to predict. So how will you predict? So basically you already have this kind of data, that is the last data that we already saw right now, that is past data that we already saw right now. So when you're going to predict, it's all about the future, right? So when it's about the future, it's going to be the same parameters or the different parameters, and if it changed, how will your actual data or how will your actual graph change? Okay, that's all about your predictive. So when I'm talking about predictive, I'm talking about, let's just take, yeah, the example of your weather. So at next week, what will your weather be? Will your weather be too hot or too cold? Oh, how will you know? But, especially when a cyclone is there, how will you, cyclone is another parameter, as I said, right? So it should predict, okay, for the next particular week. So this is what your predictive analytics is. Okay, so for this, we'll be using machine learning, algorithms, artificial intelligence. Yeah, I'll be telling about what all those are, but just these are the steps. Okay, and the last one is prescriptive. So what is prescriptive is that you are, it's just nothing but after everything, after let's just take this doctor example instead. So after a doctor analyze you fully, or just give treatment to you and just do everything to you, at last when you're going, he will prescribe some medicines, like prescribe some things for you, right? It's the same way as in your data. So what you will do, you'll see the data, you'll analyze it, and you will just see what are the parameters that are affecting, and you will predict it. And at last, when I give my new set of data, it prescribes, okay, it's going to be like this. It's, for example, if I give me that um, at this point, if at, let's say for 4 days, it's going to rain continuously at 4 p.m. Okay, if that's the point, if I'm going to ask for the next day also, I can predict that it's going to rain on 4 p.m. because it was raining for the past 3 days. Okay? So this is like when I give a new data, new set of data, it is prescribing on its own. Okay? Whereas in predictive, it is only for that data point. Like for example, I'm just asking for the I'm just giving the past data and I'm asking for the new data point. But in prescriptive, it's going to be the whole new data set is going to predict on its own. Okay, so basically how will you achieve that? So all the steps from the start you saw. So all the steps, all the levels of your predictive analytics, you're going to combine that and you're going to produce this prescriptive analytics, which is the most powerful and the final phase. Okay, after this final phase, you can have the graph and you can just have the predictive graph in your hand. Okay, so that you can say that okay, it's going to be like this for next few years or like or otherwise. Okay, so when I just explain it so theoretically, it's maybe you can't understand it, but you'll just see the use case of it also. Don't worry. Okay, so the next one is big data. So what is big data? So wait, why are the main topic is actually about predictive analytics, right? So why are we actually going into big data? So I already told you the basic thing, anything that could happen in predictive analytics is because of data, right? So if you don't have a data in the first place, you can't go for prediction itself. So that is information. When I say data, I told you about information. So I have past information and I can use it for uh, future prediction. And how will I use it for future prediction? I'll be doing some math in middle. Okay, so this is how. So at the first place, you need information. That is your data. If you don't have your data, you can't predict. But fortunately, we don't have that problem, right? Okay, because there is humongous amounts of data producing every second. Okay, we're going to see that. But the huge amount of data, you can see the 5 V's of big data over here. So you basically there are like so much huge amount of data that represents your volume of the data. Imagine, even if you're going to take your phone and if you're going to give your location on, just put your location on, and that I can get data from that because I can just say that at particular time using GPS, you're over here, like you're at a particular place. Or even if you text one of your friends in WhatsApp, that is also a data. Okay, so everything you have in your phone is actually data that can be tracked out. Okay, and the next one is variety. So there are sources from there are data from different sources. See, when I say about this weather forecast, I'm not just saying about the weather forecast. Every single department, or you can just say department because is studying engineering. So basically, every single department can be mechanical, or it can be anything civil, or um, any sort of department you take. Every department will produce lots and lots of data. Okay, you just name the department. I can just say what are the sources that they produce, and the sources is nothing but it's a source from where your data is coming from. So that's what that's what you say a source for in a data science. Okay, so basically it's just like light. You'll say from there, from that source only you'll be getting light, right? That's the same thing for your data. Okay, so you'll be getting like lots and lots of from varieties of field. So you have too much data and you have so much velocity. So what is velocity? As I told you right now, you can see this, right? So it's basically 60 seconds. In every 60 seconds we are producing this much of data. So that is too much for in such a small speed, right? So that's what velocity means. You're having huge data and it is actually happening in a very small time. That is basically you're getting a huge amount of data in a very small time. You're literally getting data right now in this second what I'm talking right now. So you're getting millions of data that you can collect. Okay, and the values of data. So you have to how much the value. See, Everything is data. I can just on my phone right now, and that is also a data, because it's like it's going to tell in your phone screen that phone that you have used your phone screen for this much particular time. So even that is data to your phone, right? So is that particular data meaningful to me? Okay, so that's what your value means. And the next one is veracity. So veracity is nothing but it's just uncertainty. So it can be, it doesn't need to be so accurate. All your it can be uncertain also. You're not so sure that the particular data that you have is actually correct. Okay, because there is data from so many sources. There is data from so many sources that okay, let's just take your Google form. Okay, if someone is making you to fill your Google form and ask for your, like, anything you want, your whether you're interested in this particular, okay, let's just take whether you're what sports you're interested in. When you're interested in basketball or football or anything, so actually you can also give like something different, like um, just let's say for example, you can also, you will just think that football in mind, and you can also click basketball and send it, right? So that is like, it's not so accurate. So it's not going to be all the data that you give, it's not going to be accurate. So this much is about your big data. So basically we have like lots of data. So so we can do lots of prediction also. Why? Because a data is actually like a unit for a prediction. Okay, so without data you can't do anything. So but fortunately, as I said, we are getting like lots and lots of data right now, that is produced in 60 seconds. So if you imagine if you get that much amount of data, how much predictions you can do. You can do in anything. You can, the very common prediction that is there is, yeah, your Netflix. Obviously everyone will be seeing Netflix. So in that, when your movies are recommended to yourself, how it is actually recommended. So it's going through the genre. So whatever you're going to see, you saw a romance, or you saw a comedy or action or thriller or horror. According to that, it's going to recommend you movies. Okay, if you're going to like action plus comedy, okay, it will just repeat itself. It will just recommend. You can just see the amount of recommendation that it is, percentage of recommendation that it is recommending to you. It will just say 69% and 80% or something. So that is actually the person, that you will like that particular film. Okay, because in previous in previous days, you have seen lots of action plus comedy movies, so that there is more probability that you will like action plus comedy movies instead of say horror plus romance, anything else. Okay, so this is what we are going to do. So basically, as I told you, prediction is not going to be your magic. So you have data and you will have machine learning, and for machine learning is, it's just not okay. I'll just tell what machine learning is. So basically, you'll just take the data and you'll do machine learning and you'll get predictions. And this whole process, the whole process is actually called as predict see, you're going to take a data, and you're going to take do machine learning in it, and you're going to do prediction. Okay, the whole process, we can say it as predictive analysis. Okay, or also you can say it as a model deployment. Okay, so okay, as we already told you, okay, it's basically we just saw everything about data. And also the one more problem that we have is not scarcity of data, because obviously, we are just producing a lots of data, right? It's not about the scarcity, but the other problem we have is storing the data. See, imagine I just told you that we are getting millions and billions of data in just 60 seconds. Okay, do we have that much storage with us to store everything? Obviously no. Okay, we can't store all the data that we produce. Like, we can't just, it can be possible, but not now. We don't have that right now. But most of the important data and accurate data that needed to be predicted are stored. Okay, so yeah, that storage is one of the problem of big data. Yeah, the next one is machine learning. So basically you're just having the data and giving it to machine learning. So what is actually machine learning? It's just the word itself explains itself. It's just nothing too complicated in it. So basically there is a mission. So there is a mission, and that mission is actually learning. That's all. It's just simple as that. Okay, let's just take an example for it. Imagine as a human, as a baby. So we are just when a baby learns new things, how will it learn? It learns from experience. Okay, so it learns. So what is experience? It's just information. Experience is just a piece of information that has been done in past, or that has been happened in past. Okay, so anything that has happened in past is going to be an information. So with that information I can proceed further. So for example, okay, the best example is I can just give you a baby touching a fire, right? So when it goes to fire, when a baby goes and touches the fire, so does a baby know that okay, the fire is going to we're going to burn it and going to hurt it? No. Hurt him or her? No, it's not going to. So no. So basically what will happen? So as a previous example, so for example, at first it just it takes its finger and just keep it on the finger, keep it on the fire, and it's going to get hurt. And the next time when they keep the fire, it's not going to obviously go there and just touch it again. Why? Because it has the past experience or past information. That information is like, if you go touch that, you're going to get hurt. So you don't have to do it again. You shouldn't do that again, basically. Okay, so this is similarly so similar to how your machine will learn. But how? We have feelings, so we can learn it. But how the machine is learning is that we are giving the information, that is, we are giving information in forms of data to the machine. Okay, so basically you can just take just in okay, you can just keep this in mind. Like for example, you're just taking the Excel form and you're going to say that okay, at this date it's going to be sunny, or this date it's going to be rainy. Okay, and you're going to add another parameter. Okay, you're having a cyclone or not. Okay, and you're going to have another parameter, whether what month it is. Okay, so all this information you're going to feed it. Okay, you're just writing everything in an Excel form. So you can just feed it to the computer. After feeding to the computer, you can do math, you can do statistics in it, and you obviously know what is probability is. You can also add some probability formulas to it to predict it. Okay, so this is basically what is called as machine learning. So basically a machine will learn through the data that we give. Okay, so next one is, what is a process? As I told you, we'll be seeing about the process of predictive analytics, and then what is big data, and then what is machine learning, as we saw right now. And then at last, we'll be seeing about the process of machine learning. So what is the process of machine learning is that, so you can see the data pipeline over here. So this is where your data is going to come from. So this is your database where your data gets stored. And basically when it gets stored, it's all going to be your raw data, right? When you're going to take the data and just going to store it, you don't have any process in it. Like you didn't have any clean data in it. So the next step would be obviously cleaning the data. So by cleaning the data, I'll do every essential step to make the data that is very suitable for my algorithm. So basically, I'll just take the data and clean it, and I'll give it to the algorithm. So I'll clean it in a way that is suited for my algorithm. So algorithm is nothing but, again, it's full of calculus that your data will go inside, and it will give you any form of output, useful output. Okay, So when you're going to give to the algorithm base, you'll first, you'll just give all that, you won't give all the data, okay, you have. So you'll just split your data into two. That is, you'll be using most of it for training. So training is nothing but, okay, how do we learn, how do our school system is. So for example, we are just going to um, you know have lots and lots to study, right? So apart from that, we also have a test. So basically, it's just like that to missions also. So we'll be having, let's just say that the data that we have is like 100%. From that, 80% will be for training, and the remaining 20% will be for testing. Okay. So you will evaluate it. By evaluating, I'm just telling that all your algorithms, and after evaluating it, you will be giving that for a deployment. Okay, after deployment, they will again, the cycle will be produced, because after you giving that prediction, it cannot be always correct, right? So some of the test, if it fails, it'll again go to inside your data, and it will get trained from that particular data and give the most accurate results for you. So basically, this is what's happening. You're going to take the data, clean the data, put that data into an algorithm, and you're going to get the output of prediction. And that prediction, when it comes into your real life, when you are applying for your real life, that's what your deployment is. Okay, so these are just the four main steps: collecting the data, cleaning the data using algorithm, that is your machine learning part, into the data, and then you'll be getting your prediction. Okay, so we'll go to the steps of your machine learning. So obviously, the first one, as I told you, gathering data. This one we already saw in big data also. They can be in any source or any form of data. I'm just not only talking about in a form of like whether I like it or not. Like for example, I told you about this football, whether a person likes football or basketball, which kind of sport, right? It's not only going to be about it. Even when you're even sending your voice message, in your WhatsApp or anything, even that is a data for me. Or image is a data for me. Any type of data, I can just put it and I can just take a prediction out of it. Okay, so every data has different sources. As I already told you, every field there will be having lots of sources, right? So I can just let's just take an automobile. So for example, when it's going to be this much percentage of your speed is going to be applied, and this much of your engine efficiency is going to be there. So what happens? So that is your one thing, is your parameters, and the other thing is what you're going to find. Okay, so all this is data for me. So I can gather different sources of data from different fields. After collecting the data, the main task is to store the data. Okay, and also the quality and the quantity of the data is very important. See, I don't have to take every data I get. The data which I want to predict, that is very important. So for example, I can get like, okay, when I'm going to predict my weather, I can get some sort of data that, okay, my name is something like, okay, let's just say my name is Omish, and and this is the date and this is the weather. In this, the name is so unrelated, I don't want it, but maybe the Google form asked for it, or in any other survey you gave your name and then told this, but I don't actually want your name. Okay, because your name doesn't depend in any way for my weather, right? What depends, what is the actual parameter that depends, is there any cyclone, or that particular month? That's what is going to depend. Okay, not your name. So the quality of the data, you don't have to take all the information that you want. Whatever information that you want that will affect your prediction, that's the variables, or that's the Basically, that's the variable that you will be collected to predict it. Okay. And the next one is data preparation. So this is nothing but you'll be having. So as I told you, you'll be getting the data. After getting the data, you'll be observing, right? So basically, you'll be knowing what is the mean of the data, like basically just basic information of the data. What is the mean, median, mode, and what is the maximum that data can go? What is the minimum that data can go? And how much variance it has? All your basic terms, definitions of that information that you'll be doing it in data preparation. Okay, this step is also called as data pre-processing, because pre-processing is nothing but something that you do before giving it to the algorithm, because it is very important. So algorithm is just the math formula, okay, but what about the data? If you give something wrong or some messed up data, you're not going to get very nice predictions. Okay, so in order to that, you need to prepare it well, that is pre-process it well in a such a way that is it is suitable, it is so suitable for your algorithm, so that we can get a better prediction. Okay. And the next one is data wrangling. So this is nothing but it's just totally about cleaning the data. So what all is so unnecessary. So say for example, in one data, a few of your data points are just missing. Like for example, a few of the person didn't even fill that Google form. So in that cases, you won't be having a value in it. So you'll be having a zero values or a missing values, or as we already talked about veracity in data, right? So veracity is nothing but it's just uncertainty. So it is, you're not going to be sure that this data is actually true or it's just some bluff. Okay, so that you don't know. So in that case, if you have doubt in it, you can just take all those data, because those data points will give us errors. So if it gives us errors, obviously we are not going to do a good task in prediction, right? So that is going to affect us also. And the next one is, as I already told, noise. So noise is nothing but you're just going to take all the unwanted factors or parameters that are affecting. So I'm just going to take what I want and I'm going to clean it. That is what we see right now. Okay. And the next comes data analysis. So in the data analysis is where you will be analyze, like you can just predict, okay, how the graph can go next. You can just predict just using a visualization of a graph, okay, not with the actual math and not with an actual accuracy. So this is what your data analysis is. So basically you'll be having what model that you're going to use, and you'll be having the result, but not an actual result. It's just going to be with whatever the data that you have. Okay, but you're not even going to get a lot of, a big percentage of a prediction, like a big percentage of accuracy of prediction. So it can be in a very low accuracy. So only when you apply that to your calculus and mathematics, machine learning algorithms, that's what when I say about your formulas and max and stuff, that when you combine your clean data into your algorithms, that's where you get your actual predicted list. So the next one, as I told you, right there is you're training the model. So I already told you, you're just going to, give the model. So basically you're going to train the model. So how you're going to train the model? So you're going to give all the information, that is your cleaned data, into your algorithm. So when you're going to give the clean data in your algorithm, your computer is going to learn. Okay, it's just going to do like this. It's if the parameter is going to be in a certain way, it is going to have a certain result. So that's how it is going to be predicted. And the rest 20%, as I already told you, will be for your testing it. So you'll be having some of the models, so some of the data points. So that one you will be using for testing your model, basically. So when I say testing your models, I can get the accuracy from this, because when I say testing, actually it's going to be a new data for your computer. It's not going to be the same data used for train. So train the whole data, since the whole data I'm splitting into two, I'm going to take 80 and 20. So it's not about the home that 80% that we already used for training. It's about the 20%, because that is going to be so new data to my computer. So how does it predict? How well does it predict that? So that's what your accuracy is going to be. Yeah. And the last one is deployment, as I already told you. So what is deployment? So when you have a very good uh, any sort of a prediction methods, it can be clustering, or it can, okay, these are the process. There are different processes how you can, there are lots of algorithms can be used how to predict. So when this is seems to be a success for you, like say for example, when it is going to have an accuracy with a nice data, pure data, and it is going to have an accuracy of like some, so 97 95% or 96%, it's totally a good model, right? So that can be sent for deployment. That is literally we can use it in a real time. Okay, just like what I said about your Netflix and your weather forecasting. So that is all deployed uh, model. Okay. Okay. The next one we are going to see is about why is predictive analytics so important? So why do you even have to learn about this? Okay. The thing is, first one is about detecting fraud. So now there is, as I already told you, like I can get data from any source, okay, or any field, okay, and cybersecurity is one of them. Okay, so basically if I just know that at this particular time and this hacker is going to hack like in a particular way, I can just be more careful, because it's all about data, right? So it's going to come from different sources and different ways, so that I can be more predictive that if it is going to be phishing or something that is done by a cybersecurity hacker. So that means I should be more aware of it. Okay, that is if it is going to be like this, it's going to come under your spam folder, so that you don't have much attention to it. Okay, it's going to be just like that. And then your marketing campaigns, as I already told you about, if you're going to say which customer, okay, let's just take that you're going to start a business. Okay, so when you're going to start a business, what is your marketing campaigns is that, so in one part of way, that okay, if you are going to keep your shop or somewhere over in this particular area, you'll be having lots and lots of profit. Okay, so how will you know that? It's basically because of prediction. Okay, because let's just take, there's a school nearby it or something. So there's a school nearby it, obviously there will be more profit over there. Okay, so you'll be getting the data from the customers, that okay, it's going to be a school student, and this much students have been come, and this is the profit that you got from the school students alone. Okay, so that is, you'll be for everything. So if you're going to start a business, or even if you're going to just sit idle at home and take the phone, and you have to be very careful with it, right? Because you have all the data in it. So in that case, you'll be using your for cybersecurity, you need your predictive analysis, and for basically anything you can see and improving operations, that is the same thing as your what I told for your um, any shop that you're going to give, at what area that you're going to give, and basically reducing risk. Obviously, if you're going to see the future, that it's going to be in this way, it will be reducing risk for you, right? So you won't take that risk, because since we are having lots of information with us and lots of data with us, and we are predicting it, and that if it's going to be in loss, no one will go for it, right? So it is useful like, in a very humorous ways. This is just some of your ways that it is useful for your, why your predictive analytics is very useful. Next, we'll see about what are the skills that needs to be developed. See, we are talking about data. So that is basically a large part. It is going to be so as we already told, I already told you about the three V's and the five V's, sorry, that we spoke about. So it's going to be like you're going to have numerous amounts of volume in such a short time. Okay. So what you're going to do, you have to use, you can't just calculate it manually. You can't just think like, okay, 3 plus 4 plus. No, you can't just do it, because there is lots and lots of amount of data. So you'll be using statistics mainly for taking the data and cleaning the data, and also for probability, for just seeing the insights about it. And the calculus, as I told you, you have to use any algorithm. So if it comes to predictive, so you have to use any machine learning algorithm to get a prediction. So for that, you will be using your calculus, and the data modeling is just your data visualization. Okay. And then what is computer science, like what, how we basic, the basic information about your how your computer works, the fundamental skills about it. And then any ML programming languages, like mainly your Python. So since everywhere Python is being used nowadays, so mainly Python or R or C++. So these are the skills that you need to be developed for your predictive analysis. Okay. Yeah, I'll come to this. So I told you, like, we'll be seeing about a use case. So yeah. So you can see this use case. Okay. So these are just only it's these are just a, a set of things called libraries. So basically, only if I import them, I can get access to all the functions that I can use under them. Okay. So I'm just going to skip this part. So you can see this is the data. So okay, when I say data, this is the actual real life example that I'm going to talk about. Okay. So you can see, okay, you can leave this part. This is that 886 and 887 part. That is just your index, just like your 1, 2, 3, 4. And since I've given tail, it's from the last. Okay. If I give head, it will be from first. Okay. So your first thing is going to be your passenger ID. Just that is same as your roll number or something. So next one is whether the survived or not. So this is actually basically, this data set is actually a Titanic data set. That is, the persons that have been in your Titanic is actually survived or not. If they survived, what are the other parameters that actually affected your whether they how they survived. Okay. The next one is what class they went, and the name and the gender of them and the age, and whether they have a siblings or other persons or not with them, and their ticket, their fare, their cabin and embark. Embark and P class is just same. Like for example, in this embark, it's just like first class. Inside first class is going to be S or C or Q. It's just like that. Okay. So I have this data. Okay. Basically, what should be my aim is that when I give new set of parameters, say for example, I'm just going to give some name, because name doesn't matter. I can just take off that whole column. And if I just give female, okay. So if I just give female, and if I just asked whether it has been she has been survived or not, so that means how much probability of this particular gender has survived, or how much probability at this particular gender have been not surveyed. So you can see, so this is the general information. As you can see, this is the first step we will be doing in your predictive analysis. So why we'll be doing this? Because you should know what is that data. So you should know what is the data that you're actually dealing with. So is that does that have what kind of parameters that the data has, or what kind of how it is related, and whether they have null values, or what type of what types of data set they have. I guess you can see it, right? Yeah. So what type of data set they have, and these are all very important, because As I told you, as the first I told you, right, a descriptive analytics. So in descriptive analysis, you'll be seeing the data and giving me how it is different, like how different variant it has. And the next one you can see in describe. This is also come under your descriptive. So basically, you're just observing the data till now. I have not touched or I'm not modified the data in any way. So I am just going to take the data and I'm just going to analyze it how different. So you can see that the total count of the data is going to be this much, and what is the mean of a particular column. So you can also notice that when I say dot describe your name and your sex part and your cabin, and that and all didn't come. So what it came, the things that came was all in your numbers. So survived is in your numbers, your p classes in your numbers. So basically everything that came is actually in your numbers wise. Okay, so you can see this. So what is the minimum value of that particular column, and what is 25% of the particular column, and what is 50% of that particular column, and 75% and the maximum. So these all are, I'm just observing how different my data is going to be. Okay, so this is the next one. It's going to be very important because as I already told you, we are going to see about whether it has a null value or not. So does it have a null value? See, I'm just going to give dot is null. So that actually means that no, it's not going to have any null value. So all the false means that there is some value in it. And here you can see for cabin, I'm seeing a true for here. So you can go here. Yeah. When I go to the cabin part, when I see the first part over here, I can see there's NAN, right? So your NAN is nothing but it's not actually zero, because zero actually has a value in all these. Like basically, if I take the survived column, your zero will be actually the person has been dead, and the one will be represented as the person is actually alive, right? So basically, zero represents something. So I can just put zero over here. So instead, I can just keep it as none. Okay, I can take the whole column off, or I can do any other sort of modification so that your data remains the same. Okay. So you can see these only in cabin part, there are like lots of null values that you can already see. So what is the not null? So is dot is null is just as opposite as your not null. So what you're going to do, you're going to see where all your passenger has been, I mean, where all your data sets has been no null values in it. So basically whether it has zero, where it has zero, and what is if it has zero, it is going to come as false, and if it doesn't have zero or it has any values, it's going to be true, right? So yeah, this is what I was talking about. So this one you're going to see that how on your gender, so how much percent your male is going to be, how much percent your female is going to be. Let's just take 577% of your male and 314 of your female is going to be there. Okay, now I can say, because what I'm going to predict is whether that particular person can be any, it can be any person, it can be male or female, it can be any sort of person. So how will I know? How will I actually know that this sort of person has been survived or not? Right. So the one such way you can see there are like lots of columns in it. Passenger ID, survived or not. So survived or not is what we are going to see about. Okay. So you can see about the P class name, the sex, the age, and stuff. So I'm not going to go for the age. So since my gender is going to tell me whether a person is not going to say, I'm going to take my gender first. So you can see with the data that I have already, so I can just group by. So I can just use these two particular columns to tell me that whether they are going to have impact on survey whether a person have surveyed or not. So you can see that for female, so you can see that for a female to be survived, the percentage is actually 74%. Okay. But a male to be survived is actually 0.1%. Okay. So basically in Titanic, so if so that means with this data, I can just say that if that particular person is going to be a female, I can just say that okay, there is more percent that the person have been saved, okay, or has been survived, okay. And if there is a male, then I can say that there is more percent that that particular male has been not saved, because just because of the gender difference, I can say that because we have a lot of difference. It's going to be 74% to 1%. So it is basically a lot of difference. So here you can see the graph. So when you come to predictive analytics, you're going to totally work with your data, right? So when you're going to totally work with your data, you will be recognizing all with your visualization. See, when I just give you a data like data set like this, anyway, this is called as a data frame. When it is not in a very tabular column way, it is actually called as your data set. Okay, so when I give it like this, nobody can actually tell me that okay, when it is going to be a female, it is going, they are going to have being survived or not. No, no one can say this. Okay? Only when I take all the females and all the males and do statistics with them, I now I can say that if it is going to be survived, like sorry, if it is going to be female, the the amount that the percentage that person is going to be get saved is actually more. You can see it is coming till 75. So here you can just see it's going to be just 18. Okay, so there is a difference in this. There is a huge difference in this. And similarly, you can just take for your age also. Okay, so if you're going to take for your age, so what will happen, you'll be having your count with you and you'll be having your age with you. So that count represents whether that person has been survived or not. So here you can see this is a separate graph and this is a separate graph, and this graph represents a person have been not survived and on the age. Okay, so basically I can say that from from your 20 to your 40, your they have not been survived that much. And you can say the same over here. It is also the same over here also. So you can just see 20 to 40 the people at the age of 20 to 40 has been survived. And why it is like this? It is because, so it is like this. It's basically because the most of the people that have been traveled is in the age of 20 to 40. So in that case, it can't be like okay, if it is surveyed, if they have not surveyed now, it's going to be in 20 to 40%, and if they have surveyed now, it will be 40 to 6% more. It can't be, because the most people that survived in the ship was 20 to 40 age, within 20 to 40 age. So within that, anyway, your there is going to be a rise at your 20 to 40. But what we should note here is that what is the accuracy? So basically you can see that still the age, the person that have not survived is more compared to your age that they have survived. Okay, you can see at 30. So basically now I can tell that your age doesn't give me any actual values of whether they have saved or not, because most of the people has been in the way of your 30 20 to 40. So it's going to be hard for us to say. Okay. So but you should know. So this is how you will do predicting. So when next time when I ask you 20 to, when someone asks you like, or you're going to predict anything that says that whether inside this 20 to 40 age, whether they have survived or not, you can say that no, it is very hard to say it like that, but I can give you information with my gender. So whether if it is going to be a male, it's going to be less percentage, as we already said, and if it's going to be female, it is going to be a higher percentage. Okay. Okay, and all the code that I'm using is that it's just general Python with functions of your libraries in it. Okay, so you have, so also when you're going to do a data visualization or data analytics, you have to know. That's why you should know about your Python and your different types of libraries that is used to do your data engineer. Okay. So this is the scattered plot of your passenger ID and your age. So this just basically says that if it is going to be a blue dot, they have not surveyed, and if it is going to be a orange dot, they have surveyed. Okay, so you can see these blue dots are not actually not surveyed, and the orange dots actually they are separate. So you can see that they have been mixed very equally. Okay, but you can also see something else. Okay, so when a person's age is above 55, you can see there is more blue dots. So that means when a person is above 50, there is very less percentage of that person is going to be surveyed. So basically that represents they have not suffered. Okay, and below that you can see all these orange dots. That is I'm talking about below 10. You can see all these orange dots, right? So what those are going to represent is that if they are going to be children, they have more percentage that they will be safe. That is especially when they are going to be in 0 to 10. So that means they have more probability that they have already been saved. So these are just some of the examples. So yeah, this is just the same with the fair. Okay, so whether that is if they give fair of that is very less, that is near to your 0, they have more probability that they actually not sub. That is basically when I tell about fair, it comes of your class. So say for example, your first class people would have been saved, and your third class people would have been not saved, like just like that. Okay, so that's what your fair represents. So if they give more fair, there is a probability that they have been um, saved. Okay, but here you can ask why the graph didn't go this much, because the persons that the total amount of persons that they have been in the fare of first class, it's comparatively very less to the economy class. Okay, so basically that's what it means. Okay, these are just different data analytics that you can see. So basically I can modify the data. So all this is going to be about your modification. So your heat map. So yeah, this is what I was talking about when I say how different parameters actually help, right? So here you can see what is the thing that we are going to find. We're going to find about the person have been survived or not. Okay, so this is the scale. Okay, you should just know about the scale. So when it is going to be so dark, it's going to be 1.1% at the max, and at least it is going to be the red. Okay, what it means is that the correlation between two parameters, that is how dependent they are. Okay, so you can see which survived and survived. So all you can see is survived and passenger ID. For passenger ID in this table is going to be all going to be green, because They are the same. I'm just comparing the same data set with another data set. Obviously, they are going to have the most accuracy. Okay, but what about the next one? You can see over here is the light green. Yeah, the you can see the light green over here. So it is basically my gender, that is my sex, and yeah. So this is basically my gender, and if they have survived or not. The dependency is more comparative to all the other dependencies. So I can also say that, see, the fair and whether they survived or not has not given me, okay, it given me like some sort of values, but it is not as helpful as my gender is. So I can just, as I already told you right now, if it's going to be a female, it's there are more probability that that person have been surveyed, right? So you can also see that, okay, if I'm going to take this red, so that with fair, okay, so you can see that the fair and the P class is not going to have that much of your codependency, okay, and that's the same uh, case with your P class and your survey. Okay, so this is what your heat map. So basically, all this is actually how to modify and how to visualize your data, and what do you think that the particular parameter is going to affect your target parameter. So here your target parameter is survived or not. So that whole survived column will be your target variable. Okay. So this is how you will be predicting it. Yeah. So this is a part of your first two levels of your, the data analytics part. The first, how you'll observe it, and then report it, and then you'll come for cleaning it, right? So that this is the first two parts. This is like basic part of the use case of your Titanic data set. Okay, so is there any doubt? If in case any doubt is there, I can clear.